Welcome to the Virtual and Augmented Reality STEM Education Hub, which is situated in the Faculty of Education at the University of Johannesburg. The hub is an educational technology hub which showcases high-end technology, including virtual reality in STEM learning, augmented reality, mobile virtual reality, all other virtual labs in the form of academic technologies that are used for STEM learning. The hub is a center of excellence being developed to showcase the incorporation of high-end learning technologies in STEM learning.
Incel is a virtual reality game that has elements of strategy and science in it. Users will go on a journey of exploring the microstructure of a human cell. The objective of the game is to prevent the advancement of a virus. In the process, users will get a clear understanding of the microstructure of the cell and also the functions of organelles. This is a perfect opportunity for users to learn more about the cell microstructures, different organelles, as well as the role in cell vital activity.
Using the Ckvr app, we are able to visualize the organs and systems. For example, if we were to look at the respiratory system and then look at the respiratory disease called the asthma, we are able to see a healthy lung and also see a lung of a person with asthma. At the same time, go inside the lung to see what is happening inside. And this is very exciting because it makes learning more fun as it stimulates different senses and make learning more fast and exciting, catering for different learning styles.
Hey, so the app that I'm using today is Ckvr. This is an application that shows 3D biology simulations of human systems. Okay, so showing labels. It shows organs such as the brain, the small intestine, the kidneys, but today I'll be looking at the heart. You can see what's happening around the heart. You can see your aorta there. So on the inside, the heart is a 4-chambered hollow organ. It is divided into the left and the right by a wall called the septum. And then, so today we are going to be exploring those 4 chambers. So we have the 2 top chambers. Okay, you'll see them. We have the top there, which are the atrium, and then the bottom we have the ventricle. So at the top there we have the right atrium, and then the left atrium we have the right ventricle, and then the left ventricle. So we are going to go inside the heart now. So this is what is happening in the heart. You see your left atrium. This is what is happening there. Your right atrium, your left ventricle, your right ventricle. This is all the processes that are happening in the heart right now.
So we'll be exploring Ckvr. Ckvr is an educational application that features virtual reality and augmented reality lessons. So the lessons range from exploring coronavirus, exploring the jet engine, methane combustion, tectonic plates, and so on. However, for today we'll be exploring methane combustion reaction in augmented reality. So now I must find a flat surface to place my jig. Okay, that's right. So now we have a methane molecule here, which features the carbon atom, which is in black, and our 4 hydrogen atoms. So now we have the dioxygen molecule, which is O2, and then for the combustion of methane we have to burn methane in the presence of oxygen. So as the heat increases, the bonds between the molecules break and they rearrange to form new molecules. The two oxygen atoms attach themselves to the carbon atom, making carbon dioxide, which is CO2. And then the hydrogen atoms attach themselves to the oxygen atom, making a H2O, which is our water. So now we have new molecules, which is carbon dioxide and water, which are products of combustion. And as we can see that we still have the same number of atoms we had in the beginning. So now that justifies our law of conservation of mass. So now we'll be exploring tectonic plates convergent boundaries in augmented reality. So now I must find once again a flat surface to place my jig. That's right. So now we have our land mass here, and we'll see how tectonic plates work. So this land mass forms part of the Earth's crust, and then in our lithosphere we have the oceanic lithosphere and the continental lithosphere, and below our lithosphere we have the asthenosphere, and below the asthenosphere we have our molten core. So now the oceanic lithosphere and the continental lithosphere tectonic plates will push into each other, and then this is called the convergent boundary. But now, because the oceanic lithosphere is heavier, it will be pushed under the continental lithosphere, and due to pressure and heat it will break apart and will be taken to the molten core. So now the hot melted rock will rise to the Earth's surface and break through the crust, and then causing volcanic eruptions. These volcanic eruptions, as you can note here, can be very violent and can be heard from distances afar. However, after cooling, the melted rock solidifies and then forms a new landmass, and then after some time the new landmass is survivable by life and plants. So now we'll be exploring the Geogebra 3D calculator. Students can use this software to create 3D visuals on coordinates, since this one now features the z-axis in contrast to the traditional y and x-axis we know. So now learners can draw some very extraordinary graphs here. For example, z is equals to x squared was plus and then y squared. So as you can see, this is not a very traditional or familiar graph, because now we are featuring the z-axis. Students can use this software, teachers in fact can use this software as an introduction to slope as a topic, to teach gradient and to teach some physical sciences concepts such as vectors and so on, anything that needs to be drawn on a set of coordinates. Applying virtual and augmented reality into mathematics, we also use the Geogebra augmented reality application. So here I must move the device slowly to find a flat surface and then place my graph as well. So as you can see as well here, it features the untraditional z-axis compared to the y and x we know, and we can draw some very nice graphs here. So students can use this one to create 3D objects and decompose nets for investigation. Plus y plus 5. Then we just do this. As you can see now, the graph appears as a 3D plane as compared to just one line that it would have appeared as if we were drawing it on the x and y axis graph.
So now we're going to be focusing on physics lab in AR. This educational augmented reality application. We learn science by doing experiments in your virtual lab with physics lab AR. Play with various circuit components and build your own circuits, classical mechanic and celestial mechanic experiments, and see how they work in real time. Anyone can enjoy the fun of scientific experiments. This application is perfect for students to learn physics interactively and for teachers to demonstrate physics experiments in class, and for students to explore inside and beyond the classroom. Another application that will be focusing on is AR Looper, which provides diverse interactive AR applications in chemistry, biology, space science, physics, and general education. I'll now showcase the change of state of matter lab in this platform. In the state of matter, we'll be looking at various states of water, that is, the liquid, solid, and gaseous state.
In the case where a large lecture venue or a large group of participants have to participate in interactive 3D learning at lecture halls and venues, a 3D projector is used to showcase 3D images in a semi-interactive fashion during lectures.